Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2.
Hello and welcome to Gardeners of the Galaxy, the podcast for all of the sentient beings in the universe who have a passion for plants. I am Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. It's hard to believe, but it's been 3 solar orbits since Gardeners of the Galaxy first launched. It has been a wild ride, with mission specialists ranging from NASA scientists and industry experts to student investigators and resourceful Earth gardeners. We've seen some remarkable astrobotany experiments over the last 3 years, including Arabidopsis growing in genuine moon rock, flying duckweed, robust space radishes, and red-hot zero-G chilies. So when I was thinking about how to celebrate the show's 3rd anniversary, I struggled to come up with a specially festive topic for the occasion. And in the end, I decided to do something I would really enjoy and spend some time delving into the archives to learn more about some of the older spaceplant experiments that have caught my attention. So I have a trio of related stories to tell you. We'll get to that in a moment, but first I'd like to say a big thank you to everyone who has supported the show with thoughtful guest appearances, generous financial donations, and kindly word-of-mouth recommendations. The show wouldn't still exist without you, and I'm very grateful. There are many ways to support the show, and if you'd like to be part of the Gardeners of the Galaxy community, you can find out more at theunconventionalgardener.com/boosters. And now it's time to get this party started, so grab yourself a mocktail from the ESA Space Juice Bar, open a packet of astronaut ice cream, take your seat in the auditorium, and I'll tell you some stories about trees in space. So far, most of the research on how to grow plants in space has concentrated on relatively small, fast-growing species, and that's not surprising because there are a lot of constraints for space experiments. Ironically, there's always a lack of space in spacecraft. Payload mass needs to be minimised because of the cost of launching it into orbit. Consumables such as energy and water need to be carefully budgeted. Astronauts face an astronomical workload. But if we're contemplating a future of long-term survival in space and on other planets, then we need to be able to grow larger plants and keep them alive for longer. And, remarkably, there have been some experiments on growing trees in space. In episode 39, we spoke to a scientist behind one of them. Dr. Carl Carruthers told us the very entertaining story of how he helped the UAE grow a palm tree in space. It was just a seedling, though. Other tree seeds have been sent into space, including Australian wattle seeds, which we heard about in episode 44, pips from Newton's apple tree, which Jeremy Curtis talked about in episode 40, and Japanese cherry pits that I covered in a recent edition of the Gardens of the Galaxy newsletter. And there are some indications that loblolly pine seeds were grown in NASA's Plant Generic Bioprocessing apparatus, which flew on the Space Shuttle and also on the International Space Station. If loblolly pine sounds familiar, it's because it's one of the species that flew to the moon and back on Apollo 14 in 1971 and became part of the first generation of moon trees, which I talked about in a bonus episode for my Patreon supporters. Loblolly pine seeds also flew on Artemis 1 last year. And while the moon trees are quite famous, it turns out that another batch of tree seeds was sent into space in the 1970s, which has been almost forgotten. Last year I came across a photo in the NASA Image Library. Taken at Johnson Space Center in June 1975, it shows USDA Forest Service Project Coordinator Glenn Kovar presenting a small wooden box to astronauts Vance Brand, Thomas Stafford and Deke Slayton. The caption explains that this special box contains enough genetically superior white spruce seeds to plant an acre of trees. The seeds were to be presented to the Soviet cosmonauts involved in the US-USSR Apollo-Soyuz test project docking in Earth orbit mission in 1975. Developed by the Forest Service's Institute of Forest Genetics in Rhinelander, Wisconsin, the seeds would produce faster-growing trees of exceptional height and shape that would thrive in a Moscow-like climate. The presentation box was made from recycled fibres and stabilised walnut. There's a lot of detail to unpack there, so let's start with the mission. The Apollo-Soyuz test project was the first international partnership in space and the first international human spaceflight. The idea behind it was to test the compatibility of rendezvous and docking systems and the possibility of an international space rescue. After launching on the 15th of July in 1975, America's Apollo spacecraft docked with the Soviet Soyuz 2 days later. During nearly 2 days together, NASA's 3 astronauts and 2 Soviet cosmonauts carried out 5 joint experiments and exchanged commemorative items, including those tree seeds. The whole thing was a technical and political success, but sadly, not long afterwards the Cold War heated up, and international cooperation in space was off the table for decades. In July 1975, the USDA produced a press release about the new products of Forest Service research being sent into space, a special box, it says, containing an acre's worth of superior tree seeds. The seeds were white spruce, offspring of parent trees developed by Forest Service scientists at the Institute of Forest Genetics in Rhinelander, Wisconsin. Noting that the climate in Rhinelander is similar to that of Moscow, it says that these trees would grow quicker, taller and hardier, with the idea of supplying a timber crop for a growing world. They would also provide oxygen, act as windbreaks, and add beauty to the lucky area of Russian soil on which they were planted. The presentation box was made from two products developed by the Forest Products Laboratory in Madison, Wisconsin. The top was chemically stabilised walnut, which would not shrink, warp or rot and was resistant to insect damage. The bottom half was a composition wood created entirely from recycled fibres, municipal waste material. There's also a lovely page detailing the other roles wood was playing in the space programme, including the cork, protecting the Apollo command module from heat during re-entry, the balsa wood, considered as insulation to keep the hydrogen fuel cool in the second stage of the Saturn V rocket, and rosin core soldering flux bonding together electronic components. So that was one of America's gifts for Russia, some genetically superior tree seeds, specially chosen to grow well in the Russian climate and nicely packed in a state-of-the-art wooden box. No doubt the Russians were chuffed to bits, but these diplomatic exchanges are all carefully worked out in advance so that the gifts are appropriate and reciprocated. So what did the Russian cosmonauts pack in their cosmic gift basket? There's always less information available on the Russian space program, especially in English, but I did manage to find out that the Russian cosmonauts presented the Apollo crew with Siberian larch seeds. I also managed to discover that the American seeds were planted in the main botanic garden of the USSR Academy of Sciences in Moscow, and that cosmonaut Alexei Leonov later requested that some of the saplings be transplanted to his home village in southern Siberia, Listvyanka, so 20 of the 6-year-old trees were moved there. In Moscow, the space-flown seeds were planted alongside ordinary Canadian spruce seeds. The space-flown trees grew faster for the first few years, but then the differences evened out. Was that because they'd taken a trip to space, or just their superior genetics? I don't suppose we will ever know. So the American trees took root in Russia as planned, and a note from NASA indicated that the Russian seeds had been planted in America. But where? For the longest time, I couldn't find an answer to that question. NASA historian Dr. Jennifer Ross-Nazal was kind enough to search through the archives for me, but even she couldn't find a reference to the seeds beyond 1975. My inquiry to the USDA went unanswered. And then, serendipitously, while I was working on this show, I found out. The Siberian larch seeds made their way to the Institute of Forest Genetics in Rhinelander, where they were planted and remain to this day. There's even a plaque commemorating the seed exchange. So that's a nice nerdy birthday present for the show, to find a happy ending to that story. Helen Sharman was the first British astronaut blasting into orbit in a Russian Soyuz spacecraft in May 1991. During her 8-day mission, she also became the first woman to visit the Mir space station, where she conducted some plant experiments that I talked about in episode 22. In interviews back on Earth, she also mentions a small lemon tree, and she talks about it in her autobiography, Seize the Moment, saying, "We took up a tiny lemon tree so small as almost to be a bonsai. The idea of this was to see if higher plants can actually be kept alive in space. This will be important in the future if we want to be self-sufficient in space, such as during a long journey to Mars or one of the other planets. We know we can grow seeds, but producing fruit or flowers inside a spacecraft is still a largely unknown quantity." Again, because this is the Russian space program, that's about all you'll find in the English language news reports, but I always wanted to know more about that lemon tree and how it fared in space. And then in July 2021, Elsevier published a book called Biological Experiments in Space, 30 Years Investigating Life in Space Orbit by Galina Nesitalo and Alexei Kondyurin. It's a weighty reference tome detailing every biological experiment that flew on Russian crewed missions, from the Salyut 1 era in 1970 to the final mission to Mir in 2000. Professor Nesitalo knows what she's talking about. She worked on all of it. It's the kind of book you can't sit and read in one sitting. It would make your head spin. But what does it say about lemon trees? It says that a dwarf lemon tree was sent into space on Soyuz TM-10 in August 1990. It and the control plants grown in a lab on Earth originally came from Vietnam. During pre-flight preparations, it was trimmed to form a compact and decorative shape and to ensure that the leaf surface was both small and characteristic of the species. The research team also had to choose a suitable substrate for the trees to grow in and pick something called gravelin, selecting and testing soluble nutritional supplements that would support normal plant growth and development over a long period of time. The goal of the experiment was simply to demonstrate that it was possible for a tree to grow in orbit for a long time, but the tree itself was just as important for the emotional well-being of the crew, so it had to be beautiful and remind them of the joys of Earth. Professor Nessa Taylor recalls that the cosmonauts had to give the tree exactly 30 millilitres of water every 3 days, and while some cosmonauts had green fingers and loved taking care of the plants, others found it more of a chore. Struggling to ensure one particular group of cosmonauts took care of the tree, she brought up the issue with a superior who had some orchids growing in his office exactly as they were growing on the space station. At her request, he made a point of speaking with the cosmonauts about the plants and explained that he had the control experiment in his office and was watching it carefully, and suddenly there were no more grumbles about the space gardening. Apparently there were 2 experiments with lemon trees, one that lasted for a year and one that lasted for 2 years in orbit, and when the trees came back to Earth they were studied in labs in Russia, Germany and the United States. The experiment was entered into the Guinness Book of Records in 1993, and there's a picture of the certificate in the book, which reads, "The Russian edition of the Guinness Book of Records testifies that Galina Nesitalo, Alexander Mashinsky, Gennady Strakalov and Sergei Krikalev performed the experiment when the dwarf tree Limonia, 5 years old at the launch time, was growing aboard Mir Station for the first time under spaceflight conditions since the 1st of August 1990 to the 19th of August 1992. I found photos of a display at the Museum of Cosmonautics in Moscow dedicated to some of the plant experiments that have been to space. On the right-hand side there are 2 certificates from the Guinness Book of Records. I wonder what the other one commemorates." So the lemon tree that flew into space with Helen Sharman was probably the second one, destined for the 1-year experiment. In any case, the trees survived their missions, although neither flowered or fruited in space. What comes to mind when you think about Canada? For me, it's bears fishing for salmon, maple syrup and vast swathes of coniferous forest, so it's probably not surprising that Canadians would have chosen to grow trees in space, or that they would choose to do so during the first long-duration mission for a Canadian astronaut, Robert Thirsk, who spent 6 months on the International Space Station in 2009. The name of the experiment was Apex Cambium, and the principal investigator was Dr. Rodney Savage, a tree physiologist from the University of New Brunswick. His investigation aimed to improve our understanding of the fundamental processes by which plants produce cellulose and lignin, the 2 main structural materials in plant matter. Now, if I asked you to stand up and hold your arms out straight, after a while your arm muscles would feel the strain. And if you repeated that exercise on a regular basis, then you'd build more of the right kind of muscle and be able to do it for longer and hold bigger weights while you do it. And some trees have a similar physiological method for strengthening branches, which is producing what's called reaction wood. Reaction wood can be tension wood, which forms on the upper side of the branch, or compression wood, which forms on the lower side. They have different proportions of lignin and cellulose to cope with the different forces they're under. And if you think that sounds like a response to gravity, then you're in good company. But scientists hadn't been able to prove it, and a microgravity experiment offered the opportunity to do that. The reason it matters is that these types of wood have different properties, which can cause problems when wood is processed and lead to inconsistencies in finished products. Understanding when and why trees produce various kinds of wood could lead to more profitable stands of timber, which some people think is a good idea. Or, as Dr. Savage put it in his experiment summary, understanding the role of gravity in wood formation is expected to enable wiser management of forests for carbon sequestration, as well as better utilisation of trees for wood products. Cambium is the plant tissue that grows to form wood in trees, hence the name of the experiment. And the cambium experiments sent to the International Space Station involved 18 willow saplings. If you make a loop in a willow sapling, you will create areas where reaction wood should form. So if it doesn't form in microgravity, that would indicate gravity is needed for that process. Making a loop is easy enough for a tree physiologist on Earth, but trickier for an astronaut in orbit, so Dr. Savage created a special tool to help Robert Thirsk make an identical loop in each sapling, which would then be held in place with tape. The saplings would grow in the Advanced Biological Research System, or ABRS, a system NASA designed to control temperature, light, humidity and carbon dioxide, and fitted with 3 cameras to monitor growth. So in November 2009, the ABRS and 18 willow saplings blasted off on Space Shuttle Atlantis and were transferred to the ISS. Robert Thirsk began the experiment, later saying that looping the trees was one of his more interesting tasks during his mission. A similar set of trees underwent the same procedure at Kennedy Space Center as a ground control. But the ABRS wasn't up to the task of caring for the trees. This had been apparent in the pre-flight testing, during which supplemental watering had been required to keep the saplings alive. But it was too late to change anything before the flight. On board the ISS, the experiment ran into trouble and the trees were dying. Savage persuaded NASA to transplant the trees into Ziploc bags to keep them alive, but the experiment was trashed. Savage was scathing about the whole affair, complaining of organisational mismanagement and deeming it a waste of tax dollars. However, if you read some of his thoughts on the topic, he clearly had somewhat overreaching aspirations for his project. Although everyone else thought of it as purely a biological investigation, Savage thought trees could help explain the nature of gravity itself, something even astrophysicists can't agree on. So Savage had overly high expectations for his first, and ultimately only, space experiment. Still, that didn't discourage the Canadian Space Agency from growing a second batch of trees in an experiment called Apex CSA-2. This time the principal investigator was Dr. Jean Bewley of Natural Resources Canada, who chose white spruce seedlings as his silvernauts. 24 saplings launched on Space Shuttle Discovery in April 2010. NASA astronaut TJ Creamer popped them into the ABRS, so they must have been confident they'd solved the technical problems that plagued the first experiment. After 30 days, the ISS crew removed the tips of the sapling shoots and roots and popped them in the freezer. They also preserved some of the trees in formaldehyde and KSC fixation tubes, so scientists on Earth could analyse their tissue development. The primary aim of the second experiment was the same as the first, to improve our understanding of how gravity affects the development of wood. After analysing the samples, Dr. Bewley and his team concluded that although both the space trees and ground controls showed normal growth, there were differences in the expression of 27 genes, which produced a different number of molecules. The results clearly showed, they said, that trees grown on Earth respond to gravity. So, hopefully we'll see many more trees growing in space in years to come. Thanks for listening, and thanks again to my boosters for supporting the show. Don't forget that you can find the show notes on the website at theunconventionalgardener.com. You can also sign up to the Gardeners of the Galaxy newsletter for new episode alerts and bonus astrobotany content. That's it for this episode, so I'll hand you back to Mission Control. Capcom, what plant would you want to take to Mars?
Orbital Guards, this is Mission Control, confirming termination of your signal. I've thought about it, and the plant I would take to Mars would be an oak tree, because I want to breed squirrels on Mars. Mission Control out.